Hi everyone. In Algebra 3, this is going to be your lesson on lesson 56. This is the new material on lesson 56 that we will be going over. Some of this is going to just be review for you. Some of this is equations that you need to have memorized. So I would take your notes out so that you're able to record some of these notes. The first thing that we're going to look at is triangular areas, then areas of segments, and then systems of inequalities. So triangular areas, we are going to be trying to find the area of a triangle when we don't know what the height is equal to. But what we're going to be using is we're going to be using our trig functions, mostly sine and sometimes cosine, to determine the unknown height. So you're going to need your calculators too. We're going to do this by creating a right triangle inside or outside of the triangle. So if you look at this triangle that I have drawn right here, we have 16 as our base, and then we have 42 as our angle, and 12 is our slant. So I'm going to redraw this triangle right here. So this is my 12, this is 42, this is 16. So what I mean about drawing a right triangle inside, this would be my height right here. Now notice that if I ignore this line, then I have a right triangle right here. This would be my angle 42. The height would be opposite to the 42-degree angle, and the 12 would be the hypotenuse. So the trig function we would use that's opposite and hypotenuse would be sine. So we're going to do sine 42 is equal to opposite over hypotenuse, which is 12. So to get the height by itself, what you're going to do is you're going to multiply both sides by 12. Now in your calculator, it's going to be 12 times 42 sine equals. Now it gives you a height of 8.03 if you were to round, but I'm just going to leave it as is. Leave that in your calculator, because now what we're going to do is we're going to jump right into solving for the area. Now area is equal to 1/2 base times height. Now I already know what my base is. My base is 16. And then I know what my height is. It's approximately 8.03. But again, I'm going to leave this in the calculator because if I divide 16 by 2, this will just give me 8. So all I need to do to get my closest answer that I possibly can is to multiply what's in the calculator by 8. And that will give me what my area is equal to. So my area would be equal to 64.24 inches squared. So again, I would leave your height in the calculator whenever you solve for it, just because it will make it a little bit easier when you're trying to solve for the area, because your answer will be the closest to the one that you'll get in the answer key if you leave it in. If you round, your answer is going to be a little bit different from what they have in the answer key. So now what we're going to do is we're going to look at the one in your lesson. Now I want you to pause this video and I want you to try this one on your own. This is number 9 in your lesson. It follows almost exactly like the one that I just did. So I'm going to give you a second and I want you to try it. So pause the video, try it on your own, and then unpause once you have done it. Okay, so now we're going to try number 9. So if I look at this triangle, the right triangle is going to be right here. The right triangle is going to be right there. This is going to be height. And then again, sine of 55 would be opposite over hypotenuse. So sine of 55 is going to be equal to opposite, which is the height, over hypotenuse, which is 4. Now, if I were to redraw this, if you can't really see that, I'm going to just redraw that right triangle portion. My angle is 55. This is my height, and this is my hypotenuse. So that's just the right triangle taken out, if you couldn't see that. Now, to get the height by itself, you're going to multiply both sides by 4. So you should get that the height is going to be equal to 4 times 55 sine equals. Now again, just like I said on the last one, I would leave this into your calculator, but if you were to round it, it would be 3.28 would be about your height. But what you're looking for is the area of the triangle. So area, remember, is just base times height divided by 2. So what I'm going to do is I'm going to plug that in. I have 1/2 the base, which is 9, times the height, which is approximately 3.28. Well, if I divide 9 by 2, I get 4.5. So now, if I multiply my height times 4.5, I get that my area is going to be equal to 14.74. This is meters squared. And what you want to make sure that you're doing is that you want to make sure that you're in the correct unit of measurement, because sometimes they're going to switch it up on you. So you want to make sure that you're paying close attention to what they're asking for. So now we're going to look at number 10. Now number 10 is different from the ones that we were just doing because the triangle is actually going to come on the outside. So for number 10, I'm going to redraw this one right here. It's going to be very similar. My angle is 125, my base is 5, my slant is 9. So when I say we're going to draw a right triangle, we're going to draw a right triangle on the outside of the triangle. So what that means is that my height will be over here, so we're still solving for the height. My 9 is still going to be my slant, but I need to solve for the angle because 125 is the inside angle. I need to find out what the outside angle is, and that's the supplement of it. So we do 180 minus 125, which gives us 55 degrees. So now you should see your right triangle is on the outside. All I need to know is what the height is, and we're going to use sine again. So to solve for the height, you're going to do sine of 55 equals opposite, which is the height, over hypotenuse, which is 9. Again, you multiply by 9 so we can find the height. So this would be 9 times 55 sine equals. Again, I'm going to leave it in my calculator as is, but it would be estimated to about 7.37. And now I want to find the area. Now the area is going to be equal to 1/2 the height. Now my height I just found times the base. So what we could do, instead of dividing that 5 by 2, is I can just take my height that I found in the calculator, multiply it by 5, and then divide by 2. And that will give me my area to the closest decimal place, and using all the decimal places that we got in the height. So that would be 18.43. This one's in centimeters squared. Okay, so you're going to be solving for the height using sine for the most part. So now what we're going to do is we're going to look at number 11. So number 11 is a little bit different. So what we need to do is we're going to be drawing this so that we can solve for the height again. So I'm going to draw this on my paper here. So the angle is 65 degrees, the slant would be 14, base 1 would be 12, base 2 would be 25. Now when I draw the height in, the height's gonna come in right here. So ignoring this 25, again, so this is my 65 degree angle. The height is opposite of 65 and the 14 is the hypotenuse to the 65 degree angle. So now when you find the height, we're gonna use sine again. So that will be sine of 65 equals opposite over hypotenuse. Now, just like on the last one, we're gonna do 14 times 65 sine equals. Now my height is going to be approximately 12.69, but again, I'm gonna use all the decimal places, so I'm gonna leave this in my calculator as is. When I find the area, area is equal to 1/2 the height, so 12.69, times base 1, which is 12, plus base 2, which is 25. Well, we can just do some simple addition right here. So 12 plus 25 would give us 37. And now what we need to do is we need to take our height and multiply that by 37 and then divide it by 2. And then that gives me what my area is equal to. So my area of my trapezoid is going to be 234.73 meters squared. And this is what we were trying to find, was trying to find the area of the trapezoid. Okay, so this is some of the new material that we're going to be going over in this lesson, but now we're going to move on to something called area of a segment. So what you need to know is that there's two ways to find the area of a sector. The area of the sector is either x over 360 times pi r squared, or if it's in radians, you're going to use x over 2 pi times pi r squared. Yes, the pi's would cancel, so really it turns into x over 2 times r squared. When you are asked to find the area of the segment, it will say it specifically in the problem. So in number 12, it just says the central angle of a sector of a circle is 0.4 radian. Find the area of the sector. So that one's asking for the area of the sector. Therefore, we would just use this equation right here. But in number 13, it says to find the area of the segment. And that's when we're going to use this equation right here. So number 13, there's either 3 steps you can follow, or you can just use this equation right here. So what I would do is I would copy this equation down as your area of the segment. What this is, it's finding the area of the sector, then subtracting the area of a triangle from the area of the sector, and then it will give you the difference between that. And I'll show you what that is when we do that problem. So the equation is x over 360 times pi r squared minus r times r sine of x divided by 2. So my x is the degree, r is the radius, r, and r. So now what we're going to do is we're going to look at number 12. So again, this is the central angle of a sector of a circle is 0.4 radian. Find the area of the sector if the radius is 5 meters. So I'm going to go to my formula for area of the sector in radians. So that equation is right here. So it's x over 2 pi times pi r squared. So now what I'm going to do is I notice that my pi's are going to cancel. My sector is 0.4 radians, so I'm going to plug in 0.4 in for x divided by 2 times radius squared, and my radius is 5 meters. And now all you have to do is take your calculator, do 0.4 times 25, then divide it by 2, and you get that your answer is going to be equal to 5 meters squared. So it's 0.4 divided by 2 times 25 gives us what our area is equal to. So that's the area of a sector. Now what we're going to look at is finding the area of a segment. And I'm going to show you what this is visually, what you're going to be finding. The area of a segment bounded by an arc of 60 degrees and the chord joining the endpoints of the arc in a circle of radius 10 feet. So in a circle, we have a sector that's going to be 60 degrees. And what we are trying to find the area of is the area out here, in the outside portion of that. So what we are going to do is, it's called area of a segment. We can actually plug this all into one long equation, which is x over 360 times pi r squared minus r times r sine of x divided by 2. So this is the area of the sector, this whole area, minus the area of the triangle. Now the triangle will be base times height. This would be the height right here, divided by 2. And now I'm going to take my angle. So I know my degree is 60 degrees, so that would be 60 over 360. My radius they give us is 10 feet, so pi times 10 squared minus 10 times 10 sine of 60 divided by 2. Now I'm going to do this separately, and do it to as many decimal places as I need. So it's going to be 60 times pi times 100 divided by 360. So I'm going to go to a couple decimal places. I'm going to go 52.35988. So I went to 5 decimal places. And then I'm going to subtract it from, now I'm going to plug this part into the calculator. So this would be 10 times 10 times 60 sine equals, and then I would need to divide that by 2. And again, I'm going to go to 5 decimal places on this one, so 43.30127. And in my calculator, I'm just going to subtract that from 52.35988. And my answer, my difference between the two will be 9.06. And this is in feet squared. So it's the area of the sector minus the area of the triangle is what I just did. So that will give us this difference on the outside. This formula is one that I would write down in your notes. Now moving on to system of inequality. So this is something that you learned in Algebra 2, but we are reviewing it now. So if you have less than or equal to, what you need to remember is that when it's dealing with a parabola or a line, that would mean everything underneath the line. So less than, when it's parabola or a line, that would be everything underneath. If we're dealing with a circle, that will be everything inside. So this would be less than or equal to. If it's a line or a parabola, it's going to be everything under. If it's a circle, then it's going to be everything inside. Now, if it's greater than or equal to or greater than, if it's a parabola or a line, it's going to be everything above. And if it's a circle, it's going to be everything outside of the circle. So those are just a couple of things that you need to note. And in Algebra 2, I'm not sure if they went over those things with you for the circle. I know you did lines and parabolas. Okay, so now what we're going to do is we're going to look at number 14. So if I look at number 14 here, it tells me to designate the region in which the coordinates of the point satisfy the given system. So y is going to be less than x squared minus 3. So x squared minus 3 is a parabola. We know because it's x squared. And if it's less than, that's everything underneath. So that means it would be all of these sections right here. So far, for the first part of this equation, the only two sections that would satisfy would be B and D. So for the first equation, y is less than the parabola would be everything outside, so that would be sections B and D. Now if it says y is greater than or equal to x plus 1, this is my x plus 1, this is my line, and that would be everything above it, greater than, above. So that would be sections A and B. So now you know that your answer is going to be B, because that's a section that's covered by both for line A and line B. Okay, and that concludes the rest of lesson 56. Lesson 56 is going to be stamped on Wednesday. Lesson 56 is stamped on Wednesday. Under this video is where you are going to post your questions for lesson 55. Lesson 55. Under this video in the comments, please list all of your questions for lesson 55, and that will be due by 9 a.m. on Tuesday morning. I hope you guys all have a great Monday. Bye.